Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam, October-November 2024, paper 42. Let's start it. Question 1. The formula of molecules A to R are shown in the table. Each letter may be used once, more than once are not used at all. Which one is an element with triple bond? Here we have nitrogen, where two nitrogen atoms in the nitrogen molecule are joined by a triple bond, so the answer will be G. It is a product of photosynthesis. In photosynthesis, the plant uses carbon dioxide and water to produce glucose and oxygen, so the product is oxygen, and the answer is H. Which one is a fuel? Here we have ethanol. Ethanol, of course, is a fuel, so the answer will be B. Turns lime water milky. This is the test for carbon dioxide gas, where it reacts with lime water, which is calcium hydroxide, to produce the insoluble white calcium carbonate. That's why the color turns white or milky. So the substance that turns lime water milky is carbon dioxide, and the answer is D. Undergoes a substitution reaction with alkane. Alkane react with halogen in the presence of UV light in substitution reaction. So here we have chlorine, and the answer will be E. It is a colorless liquid at room temperature and pressure. The only liquid here is ethanol, so again the answer will be B. It is unsaturated. Unsaturated means it contains double bond. Here we have alkene, ethene, the first member of alkene. It contains double bond, so it is unsaturated, and the answer will be A. Is 21% of the clean dry air. This is the percentage of oxygen, so the gas here is oxygen. Again, we will choose H. And it is a reactant in the HEPA process. In the HEPA process, nitrogen reacts with hydrogen to form ammonia. Here in the table, we have nitrogen only, so we will choose G. Again, like the first one here, nitrogen, so the answer will be G. Question 2. Aluminium is manufactured by electrolysis of aluminium oxide. State the name of the main ore of aluminium. The ore is bauxite. Name the substance mixed with aluminium oxide to reduce operating temperature of the process. It is cryolite. Cryolite is used to decrease the melting point of aluminium oxide and hence decrease the operating temperature of the whole process. Why the mixture in B conduct electricity? The mixture in B is aluminium oxide dissolved in cryolite, and because aluminium oxide is ionic compound, when it is in a molten state, the ions can move, or it contains mobile ions. That's why it can conduct electricity. Here in the table, we have information about the processes which take place at the anode and at the cathode. First, write the number of electrons needed to balance the ionic half equation for the reaction at the anode. At the anode, we have two oxide ions. Each oxide ion loses 2 electrons, so we will have a total loss of 4 electrons. We will write 4 to balance the number of electrons for the equation at the anode. Write the ionic half equation for the reaction at the cathode. At the cathode is a negative electrode, so aluminium ions, because they are positive ion, will be attracted to the cathode. Each ion will gain 3 electrons to form aluminium metal. So this is the equation at the cathode. State why the process at the anode is an oxidation. Here at the anode, we have oxide ion loses electrons, and losing electron is oxidation. So it is oxidation because oxide ion loses electrons. Oxygen is formed at the anode. Explain why the main gas given off at the anode is carbon dioxide and not oxygen. The anode is made from graphite, and oxygen produced at the anode react with the graphite anode to form carbon dioxide gas, so carbon dioxide is the main gas produced. State why aluminium is used in food containers. This is a property of aluminium that it resists corrosion, so it will not react with acids in the food, and that's why it is used in food containers. Aluminium react with fluorine to form ionic compound aluminium fluoride. Complete the dot and cross diagram for the ions of aluminium fluoride. First, we will start with aluminium. The aluminium atom has electronic configuration of 283. It loses 3 electrons. So now the electronic configuration will be 2, 8. We have 2 crosses in the first shell and 8 crosses in the second shell. This is the electronic configuration of aluminium ion. And because it loses 3 electrons, now we have +3 charge on the aluminium ion. For the fluorine atom has electronic configuration 2, 7. Each fluorine atom will gain 1 electron from aluminium. So now the electronic configuration will be 2, 8. 2 dots in the first shell, and in the second shell we will have the original 7 dots and 1 cross from aluminium. And because it gained 1 electron, so we will have a negative charge. This will be for each of the 3 fluoride ions present. 7 dots and 1 cross from aluminium for each fluoride ion. Sulfur forms 2 chloride, P and Q. Chloride P has the formula S2Cl2 and chloride Q has the formula SCl2. Both chlorides are covalently bonded and have low melting point. Suggest in terms of attraction between particles why these chlorides have low melting point. These chlorides are covalent compounds, so they have weak intermolecular forces of attraction between molecules which need little energy to break. That's why they have low melting point. Chloride P, S2Cl2, forms when sulfur reacts with chlorine. Write a simple equation for this reaction. Here's the formula of sulfur and this is the formula of chlorine. They react together to form the chloride P, S2Cl2. Here is the formula of the chloride. Then we have to balance the equation by putting 2 in front of sulfur. Complete the dot and cross diagram for 1 molecule of chloride Q, SCl2. Show the outer electrons only. Sulfur is in group 6. It has 6 electrons in the outer shell. To complete the outer shell to 8, it needs 2 electrons, so it will share 1 electron with each chlorine atom. Now we have 1 shared pair between sulfur and chlorine, another shared pair between the sulfur and the second chlorine. Then we will complete the outer shell of chlorine by adding 3 lone pairs or 6 electrons. And for the sulfur atom, now it has 2 plus 2, 4, so we will need another 4 to complete the sulfur outer shell electron to 8. And here is the cross and dot diagram. Chloride P is converted to chloride Q by the reaction with chlorine in a closed system. The reversible reaction reaches equilibrium. Take care that the forward reaction is exothermic. Suggest 2 changes to the conditions which will result in decrease in the concentration of chloride Q at equilibrium. Decreasing the chloride Q or decreasing the yield. Take care that the forward reaction is exothermic, so by increasing the temperature, the equilibrium will shift backward to the backward reaction, so the concentration of Q will decrease. The second change, if we withdraw or remove or decrease the concentration of one of the reactant, like chlorine gas, so if we decrease the concentration of the reactant, again the equilibrium will be shifted backward, so the concentration of the chloride Q will decrease. So the 2 changes will be the increase in temperature and decrease the concentration of chlorine or removal of chlorine from the mixture. The rate of the forward reaction D is determined by collision theory. The rate of reaction depends upon 2 factors. First one, the frequency of collision between particles. Second, the proportion of collision which have energy greater than or equal to the activation energy. Define the term activation energy. The activation energy is the minimum energy that the colliding particle must have to react, or the minimum energy needed by the colliding particles to react. Give the symbol for the activation energy. Here is the symbol E capital and A small. Complete the table 3.1 to show the effect, if any, on when the conditions are changed, using the words increase, decrease, or no change. Changing the condition, how this condition will affect first the frequency of collision between particles. Concentration of the chlorine is increased. Of course, by increasing the concentration, we will have higher number of particles per unit volume, so the frequency of collision will increase. If the temperature increase, the particle will gain kinetic energy and they will move faster, and this again will increase the frequency of collision. So here we will see the effect on the proportion of collision which have energy greater than or equal to the activation energy. The concentration has no effect on the energy of the particles, so here we will write no change. The temperature increased the proportion of the particles that have energy equal to or more than the activation energy, so the proportion of the collision which have energy greater than the activation energy will increase. If we use a catalyst decrease the activation energy, so now we have a greater number of particles that can reach to this energy level, which is the activation energy. So again, the proportion of the collision which have enough energy will increase. The reaction of chloride P with chlorine is a redox reaction. The oxidation number of chlorine in chloride P and Q is -1. Here he give you the oxidation number of chlorine in chloride ion in P and Q. Use oxidation number to explain why. Sulfur is oxidized in the forward reaction. Let's check the forward reaction from S2Cl2. Here, chloride ion has one negative charge. So we have two chloride ion. We have a total of two negative charge, two sulfur sulfide ions. So we will have +1 charge for each ion. So the total will be +2. +2 and -2, so the molecule is neutral. For the product SCl2, again chloride ion has charge of -1, so the total charge of two chloride ions will be -2. This is balanced only by one sulfide ion, so it will have a charge of +2. Now the charge of the sulfide ion change from +1 to +2, and there is increase in the oxidation number from +1 to +2. This is oxidation. Chlorine is oxidized in the reverse reaction. The reverse reaction, chlorine here change. The chloride ion here has a charge -1, and here it's a molecule. Molecule has no charge, 0. So the oxidation number increased from -1 to 0, and increase in the oxidation number is oxidation. So sulfur is oxidized in the forward reaction, and chlorine is oxidized in the reverse reaction. Question 4. Silver bromide is made when aqueous silver ethanoate is added to aqueous sodium bromide. Here we have the equation. Silver ethanoate plus sodium bromide. The products will be sodium ethanoate and silver bromide. The method include the following steps. Step 1. Use 200 centimeter cube of 0.05 mole per decimeter cube silver ethanoate, and the volume contain 0.01 mole of silver ions. For the sodium bromide, we will use 50 centimeter cube, and this volume contains the same number of moles, 0.0 moles of bromide ion. We will filter the mixture, dry the residue until the water is removed. Record the mass of the dry residue. Complete the ionic half equation for the reaction by adding the missing state samples. For silver ethanoate, it is soluble, so it will be aqueous. Sodium bromide also is aqueous. Silver bromide is the residue formed, so it will be solid. We will write S. Name a different aqueous silver salt which could be used in step 1. The silver salt can be used instead of silver ethanoate. We can use silver nitrate, because as we know, all nitrates are soluble, so it will be aqueous silver salt, silver nitrate. Use the information in step 2 to calculate the concentration of aqueous sodium bromide. To calculate the concentration, we have number of moles of sodium bromide and we have the volume. Number of moles is 0.01 and the volume is 50 centimeter cube. So first we will convert the volume into decimeter cube. Then to get the number of moles, to get the concentration, we will divide the number of moles by the volume. The concentration of sodium bromide will be 0.2 mole per decimeter cube. State the color of the precipitate which forms in step 2. The silver bromide precipitate is creamy in color, so the color will be creamy. Use the information in step 1 and 2 and the equation 1 to determine the number of moles of silver bromide used. Use this value to calculate the mass of silver bromide formed. Here in the equation, we will go back to see the ratio. Number of moles of silver ethanoate equal to the number of moles of silver bromide because the ratio is 1 to 1. So number of moles are equal. Again, we have 0.01 mole of silver bromide. Here we want to calculate the mass of the silver bromide formed. Number of moles equal to the mass divide the MR of silver bromide, which is 188. So the mass will be 1.88 grams of silver bromide, and the number of moles, as we've just said, it is the same as silver nitrate because the ratio is 1 to 1. Name the salt dissolved in the filtrate in step 3. Here by filtration, of course, silver bromide is the residue that will remain on the filter paper, and the filtrate will be sodium ethanoate. So here the name of the filtrate will be sodium ethanoate. The recorded mass of the dry residue in step 5 is greater than the mass calculated in E because a step is missing in the procedure. Suggest the missing step. We will refer back to the steps. Here, step 3, filter the mixture. Step 4, dry the solid residue. Before drying, we should wash the residue with distilled water or rinse it with the distilled water to remove any sodium ethanoate attached to the precipitate, to remove any soluble impurities or any soluble sodium ethanoate. So this sodium ethanoate remains attached to the precipitate, cause the increase in mass. So the step that was missing here, before drying, we should rinse the precipitate with distilled water. Suggest the missing step, rinsing the residue with distilled water. Name the substance responsible for the greater mass of the dry residue. We've just said that it is sodium ethanoate that still attached to the precipitate and it causes the increase in mass. Barium sulfate can be made by the same method, but with different aqueous solutions. The same method means precipitation reaction. We need 2 aqueous solution used to prepare barium sulfate. So we will use 2 aqueous solution, 1 aqueous barium salt, which will be barium nitrate, and another aqueous sulfate salt, it will be sodium sulfate. By mixing the 2 solutions, we will have a precipitate of barium sulfate. Write a balanced symbol equation for this reaction. Here's the formula of barium nitrate react with sodium sulfate. So we will have a precipitate formed of barium sulfate, which is a white precipitate, and the other product will be sodium nitrate, which will be the filtrate, and the barium sulfate will be the precipitate. Question 5. Alkenes are manufactured by cracking large alkane molecules. State the source of the large alkane molecule used in cracking. Alkane produced from petroleum by fractional distillation. Suggest 2 conditions needed for cracking large alkane molecules. The condition needed: high temperature, which is about 500 degrees Celsius, and the catalyst, which is usually silica or alumina. This is the catalyst used for cracking. When 1 mole of dodecane C12H26 is cracked, 3 molecules of but1-ene and one other product are formed. Use the molecular formula to complete the simple equation for this reaction. Here we have dodecane, C12H26, and we will have 3 molecules of but1-ene. So the but1-ene is C4H8. We have 3 molecules, so we will have a total of 12 carbons, and 3 by 8 is 24 hydrogen. So what is remaining is 26 minus 24. We have 2 hydrogen gas formed from cracking of dodecane. Suggest the type of chemical reaction which happened during cracking. Dodecane molecule breaks into 3 butene molecules and hydrogen, and breaking down by temperature, by a high temperature, is called thermal decomposition. Propene will undergo polymerization. Suggest the name of the polymer formed from propene. Propene is alkene, it has double bond, and the polymer is called polypropene. The type of polymerization, of course, it is addition because it has double bond. Draw the part of the polymer molecule to show 3 repeated units. To draw the polymer, first we will draw the monomer, which is propene. Here is the molecule of propene, where the double bond on carbon number 1 and carbon number 2. So the addition will happen on these 2 carbons. We will break the double bond and add another propene molecule. So on carbon number 1, we have 2 hydrogens. On carbon number 2, we will have 1 hydrogen and 1 methyl group. Here is the monomer. The first carbon has 2 hydrogens, and the second carbon has hydrogen and methyl group. Then we will repeat another monomer and the third one, because he's asking about 3 repeated units. And don't forget to draw 2 open and 1 from each side. This will be 3 repeated units of polypropene. Question 6. Polyamide and polyesters are polymers. Polyamides can occur naturally or can be manufactured. Part of the structure of the polyamide is shown. Draw a circle around one amide linkage, the amide linkage which is between the carbon double bond oxygen and the NH. So this is the circle represent the amide linkage. Complete the figure to show the structure of 2 monomers needed to make the polymers shown in the figure. Show all atoms and all the bonds. So here we will draw the 2 monomers. This is the first one. The monomer with the white box has 2 NH2 groups, 1 from each side, and the second one will be dicarboxylic with the shaded box, dicarboxylic. So we will draw it here. This is the first monomer, the dark box with 2 carboxylic group and the white box with 2 amino groups. This is the first monomer and the second monomer. Name the other product formed from this polymerization. It's condensation polymerization, where water is removed, so the other product formed is water. State the term given to natural polyamides. Natural polyamides are proteins. Name the type of monomers which are used to make natural polyamides. Proteins are made from amino acids, so they are the building units of protein, or the monomers for protein. One of the monomers which form part of a natural polyamide has 3 carbon atoms. So we want to draw the monomer for the natural polyamide. The natural polyamide a protein, so the monomer will be amino acid, contain 3 carbon atoms. So we will have amino acid with 3 carbon. Here the question gives us the first carbon, and because we know it's amino acid, so it contains amino group and carboxylic group. This is the carboxylic group and the amino group. And because it contains 3 carbons, so still need to draw the third one, which will be here. This is the structure of the amino acid needed. It is already drawn here. This is the carbon atom given in the question, and this is the carboxylic group for the amino acid, and this is the amino group, and here's the third carbon, the structure of 2 amino propanoic acid. BET is a polyester. Name two types of monomers molecules needed to make polyester. The monomer contain dicarboxylic acid and the other one is diol to make polyester. Draw a part of the structure of BET which shows two repeated units, show all the atoms and all the bonds in the linkage. So the first monomer contain two carboxylic group, which is dicarboxylic, and the second one is diol, so it contain two hydroxide groups, and the molecule formed the polymer formed by removing one molecule of water and joining the two molecules together. We will start by the shaded one, CO, then the shaded box, another CO group, then the white box. Here it is blue, O and O, and here is the ester linkage. We need two repeated units, means this is the first unit and this is the second unit. Remember to draw, to leave open end from both sides. Here is the structure of the polyester. One repeat unit means it contains the two monomers together. So two repeat units means four monomers. First dicarboxylic, then diol, dicarboxylic, then diol, and open end from both sides. Here we come to the end of our exam. Like the video and subscribe to the channel to receive all the updates. Comment down below if you have any question. Thank you for watching. Wish you all best of luck.